Example 3, f of x equals the sine of x, and I'm centered at pi over 4. Let's begin all the way down to the fourth derivative. So the function is the sine of x. The derivative of the sine of x is the cosine of x. The derivative of the cosine of x is the negative sine of x. The third derivative here, the derivative of the negative sine of x is the negative cosine of x. Fourth derivative, the derivative of the negative cosine of x is just going to be the sine of x. Now let's plug in our c, and our c here is pi over 4. F of pi over 4 is going to be the sine of pi over 4, which is the square root of 2 over 2. F prime of pi over 4 is also the square root of 2 over 2. F double prime of pi over 4, negative square root of 2 over 2. Third derivative at pi over 4, again, negative root 2 over 2. Fourth derivative at pi over 4, positive square root of 2 over 2. Now let's build that formula. P sub n of x is going to equal the square root of 2 over 2 times x minus where I'm centered at, which is pi over 4, raised to the 0 all over 0 factorial, plus the square root of 2 over 2 times x minus pi over 4 raised to the first all over 1 factorial, plus negative root 2 over 2 times x minus pi over 4 raised to the second power all over 2 factorial, plus negative root 2 over 2 times x minus pi over 4 cubed all over 3 factorial, plus root 2 over 2 times x minus pi over 4 to the fourth all over 4 factorial, and then plus dot dot dot. Now let's find the series. We have the sine of x is equal to the sum from n equals 0 to infinity of. As we know, this is when n equals 0, n equal 1, n equal 2, n equal 3, n equal 4. All of a sudden, it's very obvious for two things. The n factorial in the denominator, and in this numerator, I have an x minus pi over 4 to the nth power. Now I have to figure everything else out. Well, what's left over? Well, just some numbers, right? The square root of 2 over 2, the square root of 2 over 2, negative square root of 2 over 2, negative square root of 2 over 2, the square root of 2 over 2. So let's figure out this positive and negative stuff. So we know that this guy here is positive, and this is positive, this is negative, this is negative, this is positive. Well, that's not alternating exactly, right? Because the ones I said before were positive, negative, or you're going to look at negative, positive, negative, positive. That alternates each term. This alternates two of the same, two of the other kind, two of the first kind, so two positives, two negatives. And then I think we'd keep going in that direction. Let's find out. What happens if we were to find maybe the fifth derivative here? Well, that would be a positive cosine of x, and the fifth derivative evaluated at pi over 4 would be a positive root 2 over 2. So yeah, the next one looks like it would be positive. One more just to check. What about that sixth derivative? Well, that would be negative sine of x. So yes, the sixth derivative evaluated at pi over 4 would end up being negative. So it looks like our pattern is positive, positive, negative, negative, positive, positive, negative, negative, etc. So there is a formula that gives us positive, positive, negative, negative, positive, positive, negative, negative. So let's talk about what that formula is. The formula for that, again, positive, positive, negative, negative, positive, positive, negative, negative, etc. What that is this. It's negative 1 raised to the n times n minus 1 all over 2. And let's just show that this actually gives me positive, positive, negative, negative, positive, positive, etc. for n equals 0 to n equals 6. So if we were to plug in n equals 0 here, we'd have negative 1 to the 0 times negative 1 over 2, which is just negative 1 to the 0. Well, that's going to be a positive number. What about n equal 1? Well, that would be negative 1 to the 1 times 0 over 2. That's negative 1 to the 0, which is a positive number. What about n equal 2? Well, that would be negative 1 squared times 1 over 2, which is negative 1 to the first, which is a negative number. N equals 3. Negative 1 cubed times 2 all over 2 is going to be negative 1 cubed, which is a negative number. So far it looks really good. N equals 4, N equals 5, and then I'm going to do N equals 6, and we can stop. And you don't have to do this, I just want to prove this formula to you. So negative 1, and that would be 4 times 3 over 2. So that would be negative 1 raised to the 6th power, which is positive. Negative 1, and that'd be 5 times 4 over 2. That's negative 1 to the 10th, which is also positive. And last one, negative 1 to the 6th times 5 all over 2 is negative 1 to the 15th, which would be a negative number. So it definitely looks like it works out. Positive, positive, negative, negative, positive, positive, etc. So when you are alternating like that, the formula you use is negative 1 raised to the n times n minus 1 all over 2. Now we're not done because we still have the square root of 2 over 2 that we need to deal with, but at least we've figured out how to deal with that positive, positive, negative, negative, positive, positive, etc. As I said, we have root 2 over 2, root 2 over 2, root 2 over 2, root 2 over 2, root 2 over 2. So just like in example 2, it looks like all we're doing is multiplying each time by the same number. So I'm going to write the square root of 2 in the numerator, and then that 2 in the denominator. Could have written the square root of 2 over 2 in that numerator, but I'm going to write it this way, and there we go. This is our series. I'm going to show this series in Desmos, and then I want to talk about what happens if you have something different in terms of alternating of your series. Let's show this real quick in Desmos. We have y equals the sine of x, and our other one is y equals the sum from n equals 0 to infinity, so I'll put a slider of a, and then remember it was negative 1, and that was raised to the n times n minus 1 all over 2, and then we were multiplying that by the square root of 2, and then we were multiplying it by x minus pi over 4 raised to the nth power, and then that was all over 2, and then times that n factorial. And if we look at this green graph, notice as we go to infinity, let's just give it a down to 100, notice that the green graph just becomes that blue graph. So we created a power series that mimics the sine of x centered at pi over 4. Now, note, this is the formula, this blue one right here. This is the formula that you use if you're alternating from positive, positive, negative, negative, positive, positive. But please note, if your alternation is positive, then negative, negative, positive, positive, negative, negative, positive, positive, etc. If that ends up being your pattern, what you would do is use negative 1. You raise that to the n times n plus 1 all over 2. So you end up with something that's positive, then negative, negative, positive, positive, negative, negative, positive, positive, etc. The alternation piece that you would use is negative 1 raised to the n times n plus 1 all over 2.